Welcome to the third and final question on the constructing velocity versus time graph. In this one, again, we're just repeating what the other steps are. If you will need to, please go back to the other two videos to look at them. In this video, we're going to go quite quickly through the same steps. So, let's start off with, again, breaking the graph. We break it in to 4 segments: the straight, the curve, the straight again, and the not quite so straight. Now we move over and we calculate the slopes. We have 3 that we can calculate: A, B, and C. Calculate those graphs now. As you can see, the first segment, part A, has a 0 slope. We skip the curve and we move on to this one, and we got a slope of positive 4.16, or rounded to 4.2. This third one was a little tricky because this one doesn't end, but I used, conveniently, it crosses this little point here. So from 4 to 10 in a period of 1, 2, 3, and 4 seconds. So it went over rows of 10 over 4 seconds, or 2.5. Now what we're going to do is figure out what best units can go from 0 in our velocity graph all the way to where we can maximize the amount of space available on this graph. Figure that out now. Now that you have it, you've realized that you could go in steps of 1s. 1, 2, 3, 4, 5. This is as high as we don't need to go. We don't need to be we don't need to go into the 6, but it's okay to have it that high. So it starts off with a slope of 0. Now we know that if it's a flat line, it's going to go along the x-axis for the first 3 seconds. So for the first 3 seconds, we draw our line down here. Again, difficult to see on the computer, but as you can see, it goes along. We skip the curve and we move on to time equals 6 seconds. At 6 seconds, though, now it's again a straight line, so it will be flat, but it's going to be a flat line of 4.2. So we go up to 4.2 at time equals 6 seconds, and we're going to move along until time equals 9 seconds. Again, it's a flat line because it's a diagonal in the distance graph of velocity. It becomes a straight line. Then lastly, it goes into a not so fast speed of 2.5. So we move down to 2.5, and instantly it's going to go for the remaining of the time, and it will have a flat, because it's a diagonal here, goes flat there. And it will have that nice sharp cliff right there, that nice little plateau. We go back to our diagonal, or our curve, and we're going to turn that into a diagonal by connecting the dots. And there you have it. That's your final and last velocity versus time graph. If you have any more questions, go and ask your teacher.